Now we need to address, there's a special case they call the side-side angle, or SSA, situation when it's a scenario, whenever you're dealing with law of sines. And so they're prone to this. And what happens is when you're given a side, and an angle that's not between them, you have the potential of having multiple, either a triangle that doesn't exist, like this first example here. This is a triangle that can't happen because this A is too short, can't make it all the way down. And so it's a triangle that wouldn't happen. And you see that if you came up with like sine of an angle is more than 1. Well, that's not possible, so your triangle doesn't exist. You could have this case here where you have a right triangle. This is the right triangle. And so that's all pretty normal. We've seen that type of thing before. But you could have this case where h, by the way, is your your height, where A is bigger than what the height would be. So your triangle could be this one, like so, or it could be this other one going out to here. You have to look at both cases. Now sine, if you recall, you do a sine inverse, it returns an acute value. So between negative pi over 2 and pi over 2, or between negative 90 and 90, but we're not talking about positive values, so between 0 and 90. We have to look at the case that it could have been something that, while it would be return something here, it could be an angle over here where this is just the reference angle. Call it alpha. And so we'd have to look at this part, which would be 180 degrees minus alpha. And you could just have it where you have just one triangle. So these are some examples we're going to look at now. So solve the triangle for the missing side and find the missing angle measure to the nearest tenth. So we have a side, and an angle that's not included that's not between them. This is the side-side angle scenario, as I just called it. So we want to look at solving this. So we know one of the sides here, we don't know the associated angle, so we can just go ahead and do this. We could say sine of alpha, that's 35 degrees, over 6 is sine of beta over 8. Okay, so we would cross multiply, so we would have 8 times sine of 35 degrees divided by 6 equals sine of beta. So that beta would be sine inverse of 8 times sine of 35 degrees divided by 6. So beta would be approximately 49.9 degrees. Now we have to look at this into situations. So we have this triangle as it appears, but it could also be a triangle such that it might look like this. So our beta could be the 49.9 degrees, as we just saw, or there's our gamma. Sorry, this is the 49. It could be 49.9 degrees, which doesn't match with this picture. But it could be like I described. It could be something over here so that the reference angle is 49.9 degrees. So we would look at it and say, okay, 180 degrees minus 49.9 degrees is going to be 130.1 degrees. So in this case, it looks like it's 130.1 degrees. And that gives us two different possibilities for our gamma. So in this triangle, our gamma is going to be 180 minus 35 degrees minus 130.1 degrees. And that's going to give us 14.9 degrees. In this other case, our gamma is going to be equal to the 180 degrees minus the 35 degrees minus the 49.9 degrees. And that's going to give us approximately 95.1 degrees. So that's this case here. Now we still have that, this is 35, this is 8, this is 6, but we want to find the C in both of these cases. So now we could do law of sines again in these two different cases to find what that C would be. And I would just also refer back to our alpha and 6 relationship. Knowing alpha and A, I would use that to find these. So I could use a little more space here, but I guess we'll do this here. We're trying to find C, so I'm going to put C on top. C over sine of 14.9 degrees equals 6 over sine 35 degrees. So C would be equal to 6 times sine of 14.9 degrees divided by sine of 35 degrees. And that's going to give us approximately 2.7. So in this case, it's 2.7 roughly. In the second case, do it down here, C over sine of 95.1 degrees equals 6 over sine 35 degrees. So C equals 6 times sine of 95.1 degrees divided by sine of 35 degrees. And that's going to be approximately 10.4. Okay, so that's how that process is done. Looking for the two cases. It's a little tedious, have to do two things. But let's do another one here. Example 3. It says, in the triangle, solve for the unknown side and angles. Round your answer to the nearest tenth. So again, we have side, and an angle not included between them. So this must be our gamma. There's our alpha, our beta. So what do we know? We know a B, that's our B. This is our C. So we can say sine of 85 degrees over 12 equals sine of beta over 9. So sine of beta equals 9 times sine of 85 degrees over 12, and that's approximately 48.3 degrees. Okay, so that's one of the triangles. So we could have this as 48.3 degrees, but we could also have a different triangle that, that returns this 48.3 degrees, but it could be returning a reference angle, and it's actually a bigger angle, because again, sine inverse doesn't return values in that second quadrant. So we would look for the other possibility for B to be 180 degrees minus not equals 48.3 degrees. It's approximately 131.7 degrees. So we could have a case where here's our alpha, here's beta, and then here's C, alpha, beta, gamma. And this is our 85 degrees. This is 131.7 degrees. Okay, and then we can find alpha in each of these cases and then find our A. This is B. B equals 9. C equals 12. Find our A and our alpha now. So in this case up here, again, go with what I know. I want to find, I guess I can subtract to find alpha. So alpha is going to be 180 degrees minus 48.3 degrees minus 85 degrees. So what's our alpha going to be? 46.7 degrees. And in the other case, our alpha is going to be 180 minus 85 degrees minus 131.7 degrees. So alpha is going to be what in that case? Well, I get a negative 36.7 degrees. Is that possible to have a negative one? Not possible. So we can say that's not going to happen. Okay, that saved us a little bit of work. So let's find the A now. So we would do A over sine of 46.7 degrees equals 12 over sine of 85 degrees. So A equals 12 times sine of 46.7 degrees over sine of 85 degrees. And that's going to be about 8.8. Okay. Let's go on for the last one for this part. Now the video is already getting long. Find all possible triangles if one side has length 4, opposite an angle of 50 degrees, and the second side has length 10. Okay, so I don't have a diagram for this. So we have an angle of 50 degrees. We have a side of 10. And then we have this other side of 4. Now, is this thing going to be possible? 4 seems kind of short. 4 is opposite the 50. So let's take a look. Let's see if we're missing something here. What if we call this alpha? So this is A. Call this beta, so this is B. So we could say sine of alpha over 10 equals sine of 50 degrees over 4. So sine of alpha equals 10 times sine of 50 degrees over 4. So sine of alpha would be equal to approximately 1.915. Well, that's too big. Sine can't produce something bigger than 1. So this is not possible. This is that first example in that chart that we saw up here. So it's the first case. Okay, well that'll end for this video, and we'll go on to the next one. We're going to do finding an area of an oblique triangle using the sine function.